So today I'm going to introduce the microstructure properties relations in clinch and partitioning steel. And it's kind of advanced steel recently. And this is my PowerPoint index, and I divide the whole PowerPoint into 6 parts. The introduction, the production process of the steel and the microstructure and application, the research design and advantage and disadvantage. And the introduction, clinch and partitioning steel is known as the Q&P steels, and as I have mentioned above, it's very advanced steel used in the automotive industrial, and currently the cost of this material is a little bit higher than the normal material, so maybe people want to find out how can we save the cost of this material. And this material have a very good property with high strength and critical ductility, elongation, and through this research, here is my research problem. How can this new alloy used in application? What I'm saying is that what is the cost of the material, what is the parameter of the materials, and so on. And here is the way how can people product these materials. So this production process, and it's processed by the clinch and the partitioning process. Firstly, we will put the steel in a clinch process. What is the meaning of clinch? Is the steel rapid cooling. Clinch means that rapid cooling rate, and through this clinching process, we can achieve the microstructure properties of the microstructure of the austenite and the bainite and the retained austenite. Oh, and martensite, of course, which can increase the strength of the steel and the ductilities. And it also can refine the grain structure, which means that it can increase the dislocation densities of the steel, and it can improve the hardness of the steel. Partitioning process. What is partitioning process? Is keep the temperature higher or equal than the clinching temperature, which means that it's like the martensite style temperatures. And it also can enrich the carbon content, which means that it may slightly decrease the strength of the material, but it can improve the ductility of the material significantly. And it also, as I have mentioned, it can balance the strength and ductilities, and it also can increase the retained austenite. It's the same. So as I have mentioned, there are 3 main kinds of microstructure in this kind of alloy: martensite, bainite, and the retained austenite. And how can we get these 3 kind of different microstructure? Is through the cooling rate. Cooling rate will depend on can process these kind of 3 different microstructure, and this is the picture of the picture of the microstructure in the microscope, and as we can see that the microstructure of the martensite and bainite is very small, and which means that the dislocation density is very high, so it can increase hardness. So the higher the cooling rate, like the faster the clinch process we use, so we can get the martensite and the bainite. So here is the main application of these new materials. It normally used in the automotive structure part, like because it has the high strength and suitable ductility, so it's very safe for car. And it also can decrease the fuel consumption, and this is the problem that I wonder, because I check a lot of research that the research mentioned it can decrease the fuel of consumption. But how can this material decrease the fuel of consumption? And this is the problem that I need to find out in my research. So As I have mentioned, so I have designed the research to find out some problem that I have checked. So firstly, I'm going to research what kind of parameter are needed in the automotive industry. For this process, I will buy some structural part of automotive cars. So I will test this kind of different kind of parameter in the laboratory. I think it's so we can check out. So secondly, I'm going to find out the cost of this kind of material. But for this process, it may have some disadvantage because as we know the cost of the material in the laboratory is much more higher than the cost of the material in the industrial. And thirdly, I will investigate which part of automotive material may mostly used in this of this material. As I have mentioned, the structural part may be the most may be used, but no research mentioned this. So I can find out, and I can find out through investigate the steel manufacturing companies or the automotive company, but I need to get the access. Fourthly, how can this new material decrease the fuel consumption? Maybe I guess it's lightweight or whatever, so I will find out. I will search the parameter. Maybe the weight of this material is lighter than the weight of normal materials used in the automotive industrial or the fuel consumption industrial, and I will find out in the laboratory. So according to achieve, so there are some advantage and disadvantage of this of my research. Firstly, I think I get the information from the information which I achieved in the laboratory to be very accurate. So I can learn a lot of knowledge that I have learned in the university. So I can put the knowledge we have learned in a practical use, which can really help me a lot. So it also have some disadvantage of this research because as I have mentioned, we need to buy the automotive part material, and the cost of the material may be very high. So we lack of the initial fund, and the cost of the material calculation might not very accurate because the cost of the material in the laboratory is much more higher than the cost of the material in industrial use, because it also have some we will check some information from the internet which may be very accurate because we just check this kind of information in the website. So that's all of my presentation. Thank you for your attention.